The electrical code does not mandate a specific phase for the connection of the high leg in a delta service configuration. A high leg delta service, also known as a wild leg or stinger leg delta service, is a three-phase electrical service where one phase has a higher voltage to neutral than the other two phases. This is typically achieved by using a center tap transformer on one of the phases. The center tap creates the neutral point, and the voltage from the high leg to neutral is 1.732, which is the square root of 3 times the voltage from either of the other two phases to neutral. For example, in a 240 volts delta system with a center tap on one phase, the voltage from the two normal phases to neutral is 120 volts, while the voltage from the high leg to neutral is approximately 208 volts. The reason the code does not specify which phase to use for the high leg is because the functionality of the system is not affected by the choice of phase. The high leg is simply the phase that has the center tap on its transformer winding. The important consideration is proper identification and labeling of the high leg throughout the electrical system. This is to prevent accidental connection of 120 volts rated equipment to the 208 volts high leg, which could damage the equipment. The National Electrical Code, ONEC, requires that the high leg be permanently marked or tagged with an orange color. This is typically done by using orange-colored tape or paint on the conductor. The NEC also requires that the high leg be connected to the B phase in the panel board. This is a common practice, but it is not a strict requirement of the code. The main reason for connecting the high leg to the B phase is for consistency and standardization. This makes it easier for electricians and other electrical workers to identify the high leg in different electrical systems. The high leg delta service is commonly used in commercial and industrial applications where both three-phase power and single-phase power are required. The three-phase power is used for motors and other heavy equipment, while the single-phase power is used for lighting, receptacles, and other general-purpose loads. The high leg delta service is a cost-effective way to provide both types of power from a single transformer bank. However, it is important to be aware of the potential hazards associated with the high leg and to take appropriate precautions to prevent accidental contact. The orange color coding is essential for safety and should be strictly adhered to. In addition to the orange color coding, it is also important to properly label all equipment that is connected to the high leg. This includes panel boards, disconnect switches, and any other equipment that may be accessed by electrical workers. The labeling should clearly indicate that the equipment is connected to a high leg delta service and that the voltage to neutral is 208 volts. When working with a high leg delta service, it is important to use appropriate personal protective equipment, or PPE. This includes insulated gloves, safety glasses, and other equipment that will protect you from electrical shock and other hazards. It is also important to follow all applicable safety procedures and regulations. If you are not familiar with high leg delta services, it is best to consult with a qualified electrician before working on the system. They will be able to provide you with the necessary training and guidance to ensure that you are working safely and effectively. Now let's delve a bit deeper into some practical considerations when working with a high leg delta system. Firstly, understanding the voltage relationships is paramount. As mentioned, you'll typically find 120 volts from each of the NC phases to neutral and approximately 208 volts from the B phase, or the high leg, to neutral. However, the phase-to-phase voltage between any two phases remains consistent at 240 volts in this example. Secondly, the transformer configuration itself is crucial. The most common setup involves 3 single-phase transformers connected in a delta configuration. One of these transformers is center tapped to provide the neutral. The location of the center tap dictates which phase becomes the high leg. Another configuration could involve a single 3-phase transformer with the center tapped winding. Regardless of the specific transformer arrangement, understanding how the neutral is derived is key to identifying and working with the high leg safely. Thirdly, consider the types of loads that can be connected to each phase. The 120 volts phases are suitable for standard single-phase loads like lighting, receptacles, and small appliances. The 208 volts high leg should never be used for 120 volts rated equipment, as this will result in immediate damage. 240 volts phase-to-phase connections can power larger single-phase loads or three-phase equipment if properly sized. Fourthly, proper grounding is absolutely essential. The neutral point established by the center tap transformer must be properly grounded to provide a low impedance path for fault currents. This grounding ensures the operation of overcurrent protection devices like circuit breakers and fuses, which are designed to interrupt the circuit in the event of a ground fault. A properly grounded system is critical for safety and preventing electrical shock hazards. Fifthly, pay close attention to panel board wiring and labeling. As the NEC mandates, the high leg conductor must be identified with orange tape or paint. However, simply marking the conductor is not enough. The panel board itself should also be clearly labeled to indicate the presence of a high leg delta system and the location of the high leg bus bar. This ensures that anyone working on the panel board can quickly and easily identify the high leg and avoid accidental contact. Sixthly, be aware of the potential for voltage imbalance. High leg delta systems are more susceptible to voltage imbalance than other types of electrical services, especially if the single-phase loads are not evenly distributed across the three phases. Voltage imbalance can lead to overheating of motors and other equipment, and can also reduce their lifespan. To minimize voltage imbalance, it is important to carefully plan the distribution of loads across the three phases. Seventhly, consider the use of a phase rotation meter. A phase rotation meter is a device that can be used to determine the phase sequence of a three-phase system. This is important when connecting three-phase equipment to the system, as the equipment may not operate correctly if the phase sequence is incorrect. A phase rotation meter can also be used to verify that the high leg is connected to the correct phase in the panel board. Eighthly, remember to always de-energize the circuit before working on any electrical equipment. This is the most important safety precaution that you can take when working with electricity. Before starting any work, turn off the circuit breaker or disconnect switch that supplies power to the equipment. Then use a voltage tester to verify that the circuit is de-energized. Never assume that the circuit is energized even if the circuit breaker is turned off. Ninthly, always use appropriate personal protective equipment, or PPE. As mentioned earlier, this includes insulated gloves, safety glasses, and other equipment that will protect you from electrical shock and other hazards. Make sure that your PPE is in good condition and that it is appropriate for the task that you are performing. Tenthly, follow all applicable safety procedures and regulations. There are many safety procedures and regulations that apply to electrical work. Make sure that you are familiar with these procedures and regulations before starting any work. If you are not sure about something, ask a qualified electrician for assistance. 11thly, consider the specific requirements of your local jurisdiction. Some local jurisdictions may have additional requirements for high leg delta services. Make sure that you are familiar with these requirements before installing or working on a high leg delta service. 12thly, remember that the absence of a specific requirement in the NEC does not mean that it is not important. The NEC is a minimum safety standard, and it is always a good idea to go above and beyond the minimum requirements when possible. For example, even though the NEC does not specify which phase to use for the high leg, it is still a good practice to connect it to the B phase for consistency and standardization. 13thly, always consult with a qualified electrician if you have any questions or concerns about high leg delta services. Working with electricity can be dangerous, and it is always best to err on the side of caution. A qualified electrician will be able to provide you with the necessary training and guidance to ensure that you are working safely and effectively. 14thly, remember that the high leg delta service is a specialized type of electrical service that requires careful planning and installation. It is important to understand the unique characteristics of this type of service and to take appropriate precautions to prevent accidental contact with the high leg. By following the safety guidelines and best practices outlined above, you can ensure that you are working safely and effectively with high leg delta services. 15thly, document everything. Keep detailed records of all work performed on the high leg delta system. including wiring diagrams, test results, and any modifications that have been made. This documentation will be invaluable for troubleshooting and maintenance purposes, and it will also help to ensure that the system remains safe and reliable over time. 16thly, consider the long-term implications of using a high-leg delta system. While this type of service can be a cost-effective solution for providing both three-phase and single-phase power, it is important to weigh the benefits against the potential drawbacks. These drawbacks can include increased complexity, potential for voltage imbalance, and the need for specialized knowledge and equipment. 17thly, stay up to date on the latest code requirements and industry best practices. The electrical code is constantly evolving, and it is important to stay informed of any changes that may affect high-leg delta services. Attend continuing education courses, read industry publications, and network with other electrical professionals to stay abreast of the latest developments. 18thly, when troubleshooting a high-leg delta system, start by checking the voltage at the transformer. Verify that the voltage between each phase and neutral is within the expected range. If the voltage is not correct, there may be a problem with the transformer itself. 19thly, if you suspect a ground fault, use a ground fault locator to pinpoint the location of the fault. A ground fault locator is a device that can inject a signal into the grounding system and then trace the signal to the location of the fault. This can save a lot of time and effort when troubleshooting ground faults. 20thly, if you are replacing a transformer in a high-leg delta system, make sure that the new transformer is compatible with the existing system. The transformer must have the correct voltage rating, kVA rating, and impedance. It is also important to ensure that the transformer is properly grounded. 21stly, if you are adding new loads to a high-leg delta system, make sure that the system has enough capacity to handle the additional load. Calculate the total load in the system and compare it to the capacity of the transformer and the panel board. If the system is overloaded, you will need to upgrade the transformer or the panel board. 22ndly, if you are modifying a high-leg delta system, make sure that you comply with all applicable codes and regulations. Obtain the necessary permits and inspections before starting any work. It is also a good idea to consult with a qualified electrician to ensure that the modifications are done correctly and safely. 23rdly, always use the correct tools for the job. Using the wrong tools can be dangerous and can also damage the equipment. For example, when working on energized circuits, always use insulated tools that are rated for the voltage of the circuit. 24thly, keep your work area clean and organized. A cluttered work area can be a safety hazard and can also make it difficult to find the tools and materials that you need. Clean up any spills immediately and dispose of waste materials properly. 25thly, take breaks when you are tired. Working when you are tired can be dangerous and can increase the risk of accidents. Take regular breaks to rest and recharge. 26thly, never work alone. It is always a good idea to have someone else present when you are working on electrical equipment. This way, if something goes wrong, there will be someone there to help you. 27thly, be aware of your surroundings. Pay attention to what is happening around you and be aware of any potential hazards. For example, watch out for overhead power lines, wet surfaces, and other potential hazards. 28thly, if you are not sure about something, ask for help. It is always better to ask for help than to take a risk. There are many qualified electricians who are willing to share their knowledge and expertise. 29thly, remember that safety is always the top priority. Never take shortcuts or compromise safety for the sake of speed or convenience. Your life and the lives of others may depend on it. Lastly, the information provided is for educational purposes only and should not be considered a substitute for professional advice. Always consult with a qualified electrician before working on any electrical equipment.